Hello and welcome to this live session on functions in C. Uh, I was taking data structure class the other day and many of you were actually telling that it is very difficult for you to understand. Am I audible? Am I audible to you? Am I audible to you? Okay, let me check the audio connection. Am I audible to you? Okay, yes. So, what I was telling that we were doing data structure in C, and many of you complained that you are not aware of the basic C programming. I told you repeatedly to follow my lectures on principles of programming in C language. There, I already covered the basic things like data types, operators in C, then the arrays, okay, and the practical sessions were also covered. Now the thing which I have decided to cover today is functions, and in case you have any problems in the other topics like array or control structure or operators, okay, you can ask me here. But if not, then I will proceed with functions in C. During the course of this lecture, you can always ask me the different things regarding the topics I have already covered so far. So, without wasting much time, let's proceed into today's topic called functions in C. So, what are functions? A function is a procedure or routine to complete a task. Now, consider that why we require a procedure to complete a task, because you know from your idea of algorithm that it is a step by step way to do a particular program, is not it? Similarly, suppose there is a huge task or the algorithm is too much complex, then we use the functions. Why? Because the main purpose of function is to divide the big task of the program into smaller parts, and each of those smaller parts will be called as a procedure or a routine. Okay. Now, when I break the program into smaller parts, what is the main purpose? The main purpose is to understand the program better, that is one. And the second is that if there are some problems in the program, if I for some reason need to debug it, okay, I need to debug the program, then my task become a lot easier, because I can, by looking into the function, by analyzing the function which I have written, okay, I can easily go back to it and correct the errors if any. Whereas if there were no functions, then the program would have been very long and it would have been very hard for me to debug it. Okay, that where exactly the problem is. So that is another reason why I need a function. It is the same like that in our college or university, there are different departments to take care of different works, because there could have been only one principal. Then it would have been difficult for the principal to look into everybody in all the departments. So how is the institution or the college run? It is run by, there are different faculties, there are different departments, each department is having head. The main thing is that each of these department are making the work of the principal easier, is not? Similarly, in a big program, I am using functions to break down the program into smaller parts, and each part will be called as a procedure or the subroutine. Okay, and the main purpose is to debug the program easily, and to do a complex task in a much easier fashion. That is the main thing. And also, if you want to effectively analyze the running time of the program, that how much time the program takes to complete, okay, by implementing this, by implementing function, we can effectively analyze the running time of the program also. Okay, so these are all the necessities of a function, and that is why we will learn function. Okay, now how a function is actually implemented in C program, that is the topic of discussion today. Clear? Okay, Now there are different types of functions, mainly the library function, the user defined function and the recursive function. You are already aware of the library functions. What are the library functions? They are printf, scanf. These are all the library functions. Now how do the library functions work? This is very basic. You know that we are giving a preprocessor directory and adding one header file, say stdio.h, and within that header file our function definition is already there, the prototype declaration is already there. Okay, and as such, while including stdio.h header file, we can directly call printf and scanf from the main program, is not it? That is the reason why we could have called the printf and scanf from the main program. So that is one kind of function. Now we will see in this particular topic today of discussion that how a user defined function works. Okay, and also we will look into the recursive functions, that if a function happens to call itself, then it will be called as the recursive function. So library function, user defined function and recursive functions, these are the major categorization of functions. Okay, and another important function, that is the main function. We know that program execution starts at main. So without writing the main, there is no way we can write any program. So there must be a main program, there must be a main function, okay, which will help us to execute the program. Without the main function we cannot execute any program, because our program execution always starts at main. Now within the main we were calling the printf and scanf directly, because we already included the stdio.header file, stdio.h header file into our program, and that is why you could directly call printf and scanf function. That is the main thing. That means the functions which are already defined earlier, okay, user have nothing to do with it, user will simply call it. Okay, those functions are not our concern here. Our point of discussion will be user defined function, that how we can create our own functions. Okay, and those are library functions like printf, scanf, okay, getch. Okay, these are all the library functions. Okay, now how we define a function, how we create a function, that we will learn now. Now these are the steps for implementing a user defined function. The first, we need to declare the function, next we need to define the function, and finally we need to call the function. How this thing is done, I will show you through codes, so don't worry, this thing will be taught in this session, that how we declare a function, how our work becomes easier by using functions in a program. Okay, so function declaration, that is the first step. The second step is function definition, and the third step is function calling. Fine. Any questions, you can tell me that what are the steps of implementing user defined function. The steps are function declaration, function definition and function calling. I will show you step by step that how is function declared, how is function defined, how is function called, and then I will write C programs to demonstrate the same. Any questions, you can tell me. Okay, so let's move into the function declaration part. Now why is a function declared? Okay, function is declared to determine its return type, its name and the parameters to be passed. That means what? That I am using a function in this example to find the sum of two numbers. So necessarily what should be my input? If I want to add two numbers through function, necessarily the function should take two numbers as input. Now if I want to add two numbers and of type integer, then the arguments of the function should take integer as arguments. This function should take integers as argument, because I want to add two integers number, and we know that the sum of two integers is always an integer. So the function should necessarily return an integer only. Now what should be the prototype of the function? That is nothing but a function declaration. Through function declaration we want to declare that how a function should actually behave. throughout the program. What its return type should be, that is given here. Means in the given function our return type is int. The name of the function, which is the type of work it is doing, it should be similar to that. Now since our function will be adding two numbers, so our function name is best described as sum, and the function is expected to add two integers. So the arguments which should be passed into the sum function must be integers. This is called the prototype of a function. Now if our function was to display something, say the name of a particular person, then in that case what should have been the return type? The return type should have been void, because it is not returning anything. The main purpose of the function is just to print a string, to print a set of characters. So in that case the return type should have been void. So the return type is not necessarily int, it can be void, it can be float, it can be character. So depending on what my function is doing, I will be defining the function or declaring the function in a manner that its prototype match its return type. So a similar kind of function prototype declaration for the display function would have been void display, and that is not taking any parameter. So it should have been void display. Within first bracket we are not writing anything, we are not passing any arguments into the function, if the function would have been a display function. But since this function is expected to return an integer by adding two numbers of type integer, so the function name is associated with two parameters, namely integer, and its return type is another integer. This is how we declare a function, or this is what is called the prototype of a function. If you have any questions regarding prototype, you can tell me. No questions? Okay, let's proceed. Now whatever function we have declared, we must define them. Now define necessarily means that the body of the function must be described there, that what is that function doing, that work must be actually performed within the definition of the function. Now since my function is performing the addition of two numbers a and b, so a plus b must be added within the body of the function. It is quite obvious, is not it? Because my function's purpose is to add two numbers, so the body of the function should have a plus b, and since it is returning an integer, I can write it as return a plus b. I can write it as return a plus b, because my functioning, what is my function doing? My function is returning the sum of these two numbers, and it is of type integer. So I am simply writing within the body return a plus b. I think I am clear to you. Now I will have to call the function. Now I can call this function from anywhere within the program, but in our example we will be calling it from the main. What we are doing, see, we are inputting two numbers, we are asking the users to give me two numbers, namely x and y. So this thing is very simple, that through %d %x, the value of x whichever the user enters is stored in the computer memory. Again scan a %d %y using this step, the value of y whichever the user may have entered, that is again stored in the memory. And through printf enter x and y, user are entering two numbers, namely x and y. So all these things, input operations is performed in this printf and scanf. Now the variable result is storing the value of sum x comma y. Now why I am writing here sum x comma y? Because whatever values user has given here, okay, in x and y, that value must be passed into the function as parameters. Now when this particular step is executed, that is sum x comma y, what will happen? Then a call will be made into the definition of the function. Like sum x comma y will directly call this one. Now this is called, that means x and y is passed into the function, into the calling function, that x and y will bring the call of the function into this particular place. And this int and a and int b are nothing but the prototypes, and nothing but the prototypes of the variables x and y. And you already know, you have already declared the function before, and its, you know, its prototype is int comma int. So whatever integer values I am giving, I am passing to the calling function. Okay, this value will take prototypes of that function in the form of integers. So when I call sum x comma y, directly a call is made into this function, that is int sum int a int b, and the compiler matches with the prototype which is here, it is fine, right? So when the compiler finds that the prototype is correctly declared, there is no mismatch, then you enter the body of the function, and within the body of the function what I am doing, I am returning the value of a plus b. And remember, the value of x and y, it can be confusing for the beginners, that I am calling the function using xy, but I am writing here int a int b. These are just the prototypes of the actual values being passed. Actual values are passed x and y, but int a and int b, these are just the prototypes of the actual values. And since the prototypes is defined as int comma int in our function declaration, so there is no problem, and the body of the function is being executed. So after return a plus b, what happens? Control is transferred back to the main program. After the execution of the function, that is after the body of the function has been executed, control is returned back into the main. And so what value the result is storing now? The result is storing the sum of x and y. Then simply I will print the result. Simply I will print the result as printf the sum is percentage d comma result. It is very simple, is not it? Let's do one program, then it will be better, I think. Let me open the, it is visible. Let's increase the text, increase the text size. Is it visible now? I think it is visible. So we will be writing one program which implements a function in C. Okay. So let's proceed. We will write one program, nano function add dot C. So it's open our editor. We will simply include the header file so that we can call printf and scanf function here. Let's check what I am doing. Now in the first step, I am declaring the prototype of the function. So I am just commenting this prototype declaration. This is prototype declaration. Then we have to define this function. It is obvious as per the theory which we have done. Same thing we will be doing. We were taking a and b as the arguments, as a parameter to the function, and the function is returning an integer. So simply now, since it is returning an integer, we can write return a plus. Now we have to write our main. We will declare our variables which will take input from the user in x and y. We will ask the user to enter the numbers. We will have to put those numbers in memory. So naturally we have to write this step. Is not it? In case of any question, you just write in the comment section. So these two numbers I have already entered. Now my main task is to call the function. So we should call the function and store the result in variable called result. Now if I combine them, then it will be easier for you to understand whatever I have told you. So it is sum of percentage d comma result. That's it. So what our program is doing and in what place what is happening, I am just commenting them out for your understanding. Here what we did, this is prototype declaration, and this part, in this part what we have done, we have actually did the function definition. This is function definition, and at this point we have called the function. Is it clear to you? This is the function call, and here you can see I am calling the printf and scanf function also here. See, I am calling the printf and the scanf function also. Now why I am directly calling them? Because I have already included this header file, hash include stdio.h header file. So they are not the user defined function but the library function, because their definitions and declarations are already present within this header file, that is stdio.h. Clear to you that how a function works? Program execution begins at main. So execution starts from this place. User enter two numbers, they are inputted into the memory. Function is called, control is transferred here into the body of the function, value is returned, and that returned value is stored in the variable result, and finally the result is outputted in this printf statement. And while making a call into this function, while transferring the call into this function definition, the compiler checks that whether this matches with the prototype declaration. And here the prototype declaration matches, because whatever the name of the function was, that is the name of the function. Here also parameters are int, here also the parameters being passed are int, the return type is int, here also the return type is int. Can you see? Can you look into this? Can you hear me? If you can't happen to see whatever I am telling you, okay, you will notify me immediately. So I think you are understanding. So let's try to run this program. Let's check this. So GCC. So our function name is function add.c. Let's run this. GCC function add.c -o function add. So what we have done, we have compiled this C program function add.c and created the corresponding object file as function add. And since we are creating the object file, we have given a -o as the parameter. So as such, we have compiled this. Now we should run this program. How we run this program? /function add. So two numbers we will be entering. Let's enter 3 and 6. The sum is 9. So our program has executed successfully. I have written the program in the class in front of you so that you can understand. Again, let's go back into the program. Function add.c. So this is our program. What we have done, just to verify, just to check back, that we have included our header file hash include stdio.h. Then we have declared the function through prototype declaration in sum int because our parameters are integer and our return type of the function is also integer. Next, we have defined the function as int sum int a int b because int a and b are the two parameters we are expecting to get. Okay, when we pass the value to the function during call, the reference should be passed here and the return type is int and the return value is a plus b, that is we are returning the sum of these two numbers, and from main we are inputting the x and y values from the user, storing them in memory using scanf %d %x and scanf %d %y, and finally within the result we are storing the result of sum x comma y. Okay, and sum x comma y is returning a plus b, so result will be storing a plus b at the moment and I am simply printing it. And we have compiled the program using this command. As you can see, I am using a GCC compiler. So that means I have to write GCC function add.c, which was the name of my file, and then -o function add. Why -o? Because I want this function add.c file, okay, and I to change into an object file or executable file. That is why through compilation, you know that we change the .c file into the binary executables or object file, and we have converted this into an object file. Now our object file is ready. We can simply run it from the root, and that is why we type dot slash function add. This is the step for running the program. This is the step for running the program, and then we enter two numbers. We got the sum of those two numbers. Any questions until this? You can tell me that how the sum is obtained using function. Okay. Now we will modify this method, okay, this program in a number of ways to give you a clear description of what a function is. But before going into that, let's see how a recursive function work, okay, and what is a recursive function. So you understood that printf and scanf, these two are library functions. Then this sum function is a user defined function which I defined, created and then called. Now a particular type of user defined function is recursive function. Let's understand this, okay. But what is a recursive function? Now if a function calls itself, that means here you can see what is happening. Here the main function is actually calling sum function, is not it? The main function is calling the sum function. Now if the sum function itself calls the sum function, then we will call this as a recursive function. That is, when a function calls itself, it is called as the recursive function. When a function call itself, it is called a recursive function. Suppose we are putting this one in such a manner that sum xy is calling itself. How this happens? Let's check. Let's open a file. Which is a simple test file, okay. Now how this thing happen? Suppose I am writing a function. I am writing a function here, and this function is called again from this position. That means what is happening? I am calling the function, I am calling this function from this function only. That means the function is calling itself. That will be called as the recursive function. But in our case, we were calling this sum function from the main function, so it is not a recursive function. But if in case we happen to do this task, then it will be a recursive function. Now when this thing happen, suppose we are doing a recursion, or we are finding the factorial of a number, say. So we know how a factorial of a number is obtained. Say, what is factorial 3? Factorial 3 is 1 into 2 into 3. In other words, we can say that it is factorial 2 into 3. Similarly, what is factorial 4? Factorial 4 is factorial 3 into 4. What is factorial 5? Factorial 5 is factorial 4 into 5. That means we are just using our previous result to calculate the new result. That is what the function is calling itself. Let me show you using one example. Let's take one example here. Extend this. Now we are simply writing one code here. Okay, this is our main function. We are not bothered about that. We will just create one recursive function here to find the factorial of a number. Now prototype, we have already declared that this fact function will find the factorial of a number and it will take integer as the argument. Why? Because the factorial of a particular integer is to be obtained and the factorial of a particular integer will be another integer. So the return type must be int. So the prototype of the function should be int fact int. Now we will define the fact function. Suppose a particular number whose factorial we want to find out, that should be our parameter. What we will do? Simply we will do fact n into fact n into fact n minus 1. Why we are doing this? Because what is this? What is this particular? Why we are doing this? We are using fact n minus 1 to find fact n, is not it? We are actually using fact n minus 1 to do fact n. Because what is factorial 5? Factorial 5 is factorial 4 into 5. So since our number we are inputting this, either you make it n, then it will be easier for you to understand. Let's store this value factorial that value should be n into, and what value will be returned? Return the factorial. That's it. The only thing is that we know that factorial 0 is 1 and factorial 1 is also 1. So we will include those conditions. If number equal to 0 or you can just if number equal to 0 or number equal to 1, this value will print 1. Else you have to do this. Else we are doing this. Okay. So if the number is 0 or 1, because the factorial of 0 is 1 and also the factorial of 1 is 1. So otherwise the result will be factorial n into fact n minus 1. This should be n, right? So this checking will do, and from the main we will simply call this function. That's it. We will call fact n and user will enter the value of n. user will simply enter the value of n. That's it. It should be like this. Now we are getting the full program here. That program execution starts at main. User will enter the value of n. That value will be present in the memory. Then fact function is called. Control is transferred here. In this point, int fact int n, the value of n will be passed as parameter. If n equal to 0 or n equal to 1, the result is 1, else you have to call this function again. That is, n equal to fact n minus 1 will repeatedly call this function, is not it, unless the value is 0 or 1. So this value will be dynamically stored, and as such you will ultimately get the factorial of the number. Okay, this is how recursive function works. You can check here. In this step we are defining this is prototype declaration, this one is definition, and remember we are not calling from the main this time, we were calling this function from this place. That means the fact function is calling itself. Okay. I think it's clear to you. Similarly, for Fibonacci sequence also you can do. You know that in Fibonacci sequence what happened, the sum of the previous two terms are added together for the third term. So that means how the sequence look, it is 0 1 1 2 3, is not it? That is how it just adds the previous two numbers in sequence and give you the result. So simply we can just type fib n is equal to fib n minus 1 plus fib n minus 2. As such you are calling the fib function from within itself and it will give you the Fibonacci sequence. So in this case the function is calling itself, that is why it is the recursive function. You can just check it. And in the one which we did here, in this case we normally just created one user defined function and called it from within main. Okay. So user defined function, library function and recursive function, that has been covered. If you have any question you can tell me. Any question from your side? No question? if you have already understood function, then it's okay, we are done with this. Okay, since there is no question from your side, I assume that you have already understood functions. So I have in this particular session I taught you that our user defined function declared, defined and called, and what are recursive function, how they are executed, and also I taught you that what are printf and scanf, why are they called library function, why we need not have to define and declare library function from within our program, why they can be directly called from the main program. Okay, that has been discussed because they have already been included within the respective header file. Okay, and using the preprocessor directive hash, and by including the stdio.h header file, I can directly call the printf and the scanf function. Okay, without being needing to defining them or declaring them. But that thing is not happening in case of user defined function. We have to declare it, we have to define it, and we have to call it. Okay, and the normal user defined functions are actually called from main or from anywhere within the program. But when there is a special case of user defined function, when it is called from itself, like I showed you here, that the fact function is calling itself. Okay, that special case will be termed as the recursion, that when a function calls itself. So that is a special case of user defined function. So these are the things I have already covered. Now since there is no questions from your side, I assume that that is the end of the session for functions. But I will be here for another 2 minutes or so. If you have any questions, you can tell me, not only regarding function but also regarding any other topics whichever is covered before functions. You can ask me if anything you want to clarify. Okay, then if there is no question from your side, uh, that's it for today. Hope to meet you for the next class. Thank you. Bye.